Hey, let's make a key for this handout. Find the following trigonometric ratios. To do that with right triangles, you're going to need to remember the word and what it means. SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So here is our angle theta. The 5 here will always be your hypotenuse. The 3, if we're talking about the theta where it is now, is going to be the opposite, and the 4 down here will be the adjacent. Now if the theta was to change locations, the opposite and the adjacents would swap. So be very careful about the position of the angle you're trying to find. But for number 1, the sine is going to be your opposite over your hypotenuse, and that will be 3/5. Cosine will be adjacent over hypotenuse, 4/5, and tangent will be the opposite over the adjacent, 3/4. Second drawing, this is our hypotenuse still, because of where the theta is. This is our opposite, and the 24 down here will be our adjacent. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. And tangent, opposite over adjacent. On this one here, the 13 will be our hypotenuse. Since the theta is over here, that makes the 5 over here the opposite, and the 12 down here is our adjacent. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. The 17 is going to be our hypotenuse. In this drawing, the angle theta is up at the top, which makes our opposite down here where the 8 is, and the 15 will be our adjacent. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. On the back side of this handout, I've given you 2 of the 3 sides of the triangle. So you'll need to use your Pythagorean theorem to find the missing side. C squared is equal to A squared plus B squared. I always start off with the hypotenuse. So we'll need to figure out this missing side down here. That is not your hypotenuse. 15 is. 15 squared is 225. 9 squared is 81. I'm going to subtract the 81, and then I'm going to do a square root of that. So 225, take away 81, that puts the 81 on the other side, and then I will do the square root of that, and we all know that that's going to be 12. All right, so the 15 is going to be my hypotenuse, the 9 is my opposite, the 12 is my adjacent. Sine, 9 over 15. I'm going to reduce that down to 3/5. Cosine, adjacent over hypotenuse. I'm going to reduce that down to 4/5. Tangent, opposite over adjacent. Reduce that down to 3/4. Number 6, we'll need to find this leg over here. 7 radical 2 is your hypotenuse. X and 7 are your legs. You take a 7 radical 2. When you square that, you're going to square the 7, which is going to give you 49. And you're going to square the radical 2, which cancels the radical. So you get 49 times 2, which gives you 98. Just put a square there. 98. And 7 squared is 49. I'll take 98 and I'll subtract the 49 over, and then I will do the square root of that. And we'll end up with an x is equal to 7. Sine, the angle is up at the top, so down here is your opposite. This is your adjacent. Here is your hypotenuse. Sine, opposite over hypotenuse. You should reduce the 7's. And there was a technique that you learned in algebra called rationalizing, where you multiply top and bottom by the square root. 1 in the radical 2 gives me radical 2. Radical 2 and radical 2 give me radical 4, which reduces to a 2. Cosine. Cosine is going to be my adjacent, which was that 7, over the hypotenuse, which will be the same exact thing. And tangent will be my opposite over my adjacent, and for that problem it reduces to a 1. We need to figure out our hypotenuse right here. I'm going to find 12 squared, and I'm going to add it to 18 squared. And then we'll take the square root of that. No, I am not going to do that. Let's go to our y equals, and let's figure out what the square root of 468 is in a little bit better terms. 468 divided by x squared. Go to my table, and let's look for the last nice line. 6 radical 13, that looks good. Don't think there's going to be another one, and there is not. Our answer for the square root of 468 is 6 radical 13. Sine. Sine is equal to, let's see, there is theta, so here is my opposite, here is my adjacent. The 6 radical 13 is your hypotenuse. So opposite over hypotenuse. I'm going to reduce the 18 and the 6. That gives me 3 over the square root of 3. Come over here to the side with me. I'm going to multiply top and bottom by the square root of 3. That gives me 3 radical 3 over 3, and the 3's cancel. This is just the square root of 3. Cosine. I'm going to take my adjacent and put that over the hypotenuse. Reduce the 12 and the 6. That gives me 2 over the square root of 3. Follow me back over here. Multiply top and bottom by the square root of 3. That gives me 2 radical 3 over 3. And tangent is opposite over adjacent, and that'll reduce a lot nicer by taking out a 6, 3 over 2. Number 8, let's find our hypotenuse. Three radical 21 squared, parentheses, 3 second radical 21, close the parentheses there, oops, 3 second radical in a parentheses, 3 second radical 21, close, close, square. So that's the first part. What your calculator is going to do is it's going to square the 3, get a 9. It's going to square the radical and get just 21, and it's going to put the 9 and the 21 together and get 189, I believe. Plus, and then 10 squared is a 100, so this should be 289. And the square root of 289 is 17, I believe. Boop. The theta is up at top, so this makes the 10 the opposite. The 3 radical 21 is our adjacent. That 17 is our hypotenuse. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Sine, or tangent, opposite over adjacent. Let's work on that for just a second. 10 over 3 radical 21. I'm going to multiply top and bottom by the square root of 21. This gives me 10 radical 21. A radical 21 and a radical 21 make just a 21. 3 and 21 is 63. That is an ugly, ugly answer. Hey, we made a key.